So today we will discuss about what is time travel and what is fail-safe in Snowflake. Okay, so this is very important feature in Snowflake. Okay, which is not available in the traditional databases. Okay, let's see how it goes. So the agenda is what is time travel, what is retention period in Snowflake. Okay, how to set retention period, what is the default retention period, okay, and how to query the historical data, that is modified data or deleted data, and how to restoring the objects, like if we drop some database or schema or table, how can we restore those objects again, and what is meant by fail safe, how it is useful, and what is the continuous data protection lifecycle offered by Snowflake. We'll discuss all these things today. Okay, so let's come to what is time travel. So what is time travel? Snowflake time travel enables accessing historical data at any point of time within a defined period. Okay, suppose I have some data set, and over the time I'll be modifying that data set. I'll be inserting some data or updating some data or deleting some data. And if I do that by mistake, okay, and if I want to go back to previous copy of data, and I want to see the deleted records, or I want to see the records before it was getting updated, if I want to see those all these things, then we can use time travel feature available in Snowflake. So it enables us accessing the historical data, okay, that has been changed or deleted. Okay, restoring data related objects. Okay, as I said, if we drop any tables or schemas or database by mistake, or uh, intentionally, if we drop them, okay, we can restore them again based on the defined period. Okay, we'll see what is that period in the next slide. We can restore any type of objects like tables or schemas or database. Okay, and we can query data in the past that has been updated or deleted. As I said, if we update any data or if we delete any data by mistake or intentionally we do that, we can query that data also. We can store that data, we can query that data. Okay, we can do anything with that historical data, but up to certain period only, up to certain period. Okay, and duplicating and backing up data from key points in the past. Suppose I have a weekly load, okay, and that means my data is getting changed or modified every week. Okay, suppose in future I realize that I need some data for my analysis. Okay, and if I want to take the backup of previous data, previous week's data, suppose last week my table contained 1 million row, and this week I have loaded another 1 million row. But if I want to see the last week's 1 million row, only that copy, and if I want to take a backup of that, okay, into another table, we can easily do that by using time travel. Okay, and analyzing data usage or manipulation over a specified period of times. Okay, whatever I said, it applies here also. So if I'm keep applying some changes to my data, and over a period of time, suppose in a week, if I want to know how many times I have modified my data, or how many records I have deleted, how many records I had inserted, I want to see all those information. By using time travel, we can see. That means we can track our data, so how it is getting manipulated over a period of time. Okay, and when it comes to how to apply this time travel on the tables, we don't need to enable time travel. Okay, it is automatically enabled. So whenever we create some table, based on the table type we are creating and based on the edition we are using, so time travel will be automatically enabled. Okay, and let's see, if I explain you retention period, you will understand it more easily. Okay. So what is retention period? So retention period is the key component of time travel. In applying the time travel, if we want to apply time travel for any objects, tables or schemas or databases, this is the main component, retention period. So I was saying right in the previous slide, in the specific period of time, okay, that period is called a retention period. So for every object, there will be a retention period associated with that table or schema or database based on the Snowflake edition we are using. So what are all the editions we have? Standard edition, enterprise edition, business edition, and virtual private Snowflake edition. Okay, 4 editions we have. So based on the edition, this retention period may change. Suppose for standard edition, okay, so what is retention period? Let's see. It specifies the number of days for which this historical data is preserved. Okay, suppose my retention period is 10 days. That means in last 10 days, whatever the data deleted or whatever the data modified, I can get it back. I can view that data, I can query that data, I can load that data into another table. Okay, after that 10 days retention period, we cannot query that data. Okay, so retention period is the number of days for which this historical data is preserved. Okay, so for standard edition, the retention period is 1 day, and we can set it to 0 as well. Okay, it supports maximum 1 day retention period. And for enterprise edition and higher editions like business critical and virtual private Snowflake, it is 90 days. Okay, and we can set it to anything between 0 and 90 days. Okay, so by default it is 1, even though they are offering 90 days of time travel period for enterprise and business critical editions. Okay, by default it is 1, and we can set this period at the time of creation of the table or schema or database, and we can alter it later also. So whenever we create some table, okay, by default the retention period of the table will be 1. Okay, we can see that actually in the queries we can see what is the retention period for each and every object in the Snowflake. Okay, so by default it will be 1. Whenever you create some object, the default retention period comes is 1. Based on the edition, we can set it to 0 to 90 days. Okay, so all the higher editions offer 90 days. Okay, and we can set this period at the time of creation of the table. Suppose by default is 1. If I want to set it to 10 or 20 or 30, so at the time of creation of table, we can specify what is the retention period I want. Okay, and suppose if I don't do that, I have created table without specifying the retention period, so we can alter it later point of time also. Suppose at the time of creation I I thought like 10 days retention period is enough, but after some time or after observing my data for 1 month or 2 months, I realized like 10 days is not enough. I want to increase it to 20 days, so we can set it. Okay, and the 20 days will be effective immediately whenever we alter that this one time travel retention period. Okay, and a retention period of 0 days, that means we are disabling the time travel feature for that object. So for any object, suppose I have a table and I'm setting it setting the retention period as 0 for that table by using the alter command, that means I'm disabling the time travel feature for that object. That means we cannot, if we by mistake or intentionally, if we delete any data or update any data, we cannot bring that data back. Okay, so that is mean by retention period of 0. You are completely disabling the time travel feature for that object. Okay, and we can change the retention period by using the alter command. As I said, by using alter command, we can change our retention period at any point of time. And higher retention period, the higher storage cost. You can understand this, right? Why higher retention period, the higher storage cost. So suppose I have a table and it is getting modified every day and the records inserted are deleted every time. Okay, so what will happen if we specify 90 days as the retention period? What will happen? So Snowflake has to store multiple copies of the data. Okay, for each and every modification, it has to store another version of the table. So it has to maintain so many versions of the table, so many copies of the table, even though uh, the storage layer is small, but it has to maintain all the versions data, right? Okay, so suppose I have just 1,000 rows in a table, but I'm modifying every day the data 1,000 rows. Okay, so what will happen? 90 days, if I'm modifying every day, 90 versions of the table will be required. It has to store. Okay, so definitely the storage cost will increase. So the higher retention period, the higher storage cost. Even though Snowflake is offering 90 days of retention period, organizations won't do that. Okay, they select a maximum up to 30 days only on any tables or databases or schemas. And in real time, what they do, so we cannot set it. So the admin can set actually. They don't give permissions to alter or set it. So after some discussions at the initial stage of the project, they will set the retention period at a schema wise or database wise. Suppose if I apply retention period of 30 days database wise, then by default, all the tables inside the database will come with a 30 days retention period or 10 days retention period, whatever applying. Suppose if I want to apply at schema level, if I apply 5 days of retention period for a certain schema, for particular schema, then all the tables under that schema will come with retention period of 5 days. And if we, for any table, if we want to specifically change it to 10 days or 15 days, we have to mention specifically in the table definition, or we can change it by using the alter command. So this is about retention period. So retention period is nothing but the number of days for which the historical data can be stored. Okay, and the retention period change varies based on the edition we are using. Okay, it can be 1 day for a standard edition, and it will be 90 days for all other editions, and we can set it to 0 as well. So by default it is 1, and we can set it to 0. If we set it to 0, the uh, time travel feature will be enabled for that object. And if we want to change in future, okay, the retention period, we can change it by using alter command. Okay, and with the higher retention period, the cost also will be increased. So this is about retention period. And so how to query the historical data. So as I said, right, we can query the deleted data or updated data, okay, or previous copy of data. We can easily query, but how to query? So there are three ways, okay, three ways to query historical data. One is at a specified timestamp. Suppose today date is 7th July, okay. If I want to get the data, a copy of the table on the 5th July, okay, I can easily get the data by just mentioning the timestamp. At that timestamp, what is the data? What was the data present in the table? And at some time ago, suppose timestamp is for larger periods, okay, and this some time ago means it's for shorter period. Suppose 5 minutes back, what was the data present in the table? 2 minutes back, what was the data present in the table? Or 10 minutes. So it is short time within 24 hours if we want to specify. Okay, so we use this at at offset. Okay, we'll show you that in practical today. So this is one way, and the third way is before executing any statement or query. So whenever we query, that query is associated with one query ID, right? So what we can restore the data, or we can query the data before executing that particular statement. Suppose I have some 100 records in the table, okay, and I ran one delete query on the table, deleting 10 records, okay. So whenever I run the delete query, a query ID will come for that delete statement, right? So by using that query ID, we can bring the data, okay, before that, before executing that query ID, what was the data present in the table, okay. So by using the query ID also, we can get the history data. Okay, these are the three ways of getting history data from Snowflake. And this is how we use actual SQL statements to bring the data back. Okay, or if we want to query the history data, okay, this is the way. See, if you see, the first one is below query selects historical data from a table at a specified timestamp. Suppose uh, select star from the table at, okay, this is the keyword we have to use. Select star from table at, okay, inside the parenthesis we have to use timestamp, and we have to mention the timestamp. Okay, so what is the timestamp? Before the timestamps, what was the data present in the table? We can bring that data. Okay, and if you see here, the second way, below query selects the historical data from a table as of 5 minutes ago. So I told, right, at offset we use for shorter period. Suppose we can use this for a larger larger periods also, not a problem, but mainly we use it for shorter periods like 5 minutes, 10 minutes, 1 hour, 2 hour, like that. So this query gives us the data which was present in the table 5 minutes ago. Okay, select star from table. Okay, select star from table at, we have to give this keyword at offset, at offset. And minus 60 means we always calculate in the number of seconds, the time in number of seconds. So if I want to select for 5 minutes, I have to do minus 60 into 5. If I want to select 1 hour back, okay, I have to give minus 60 into 60. Okay, if I want to give 2 hours back, okay, I have to give minus 60 into 60 into 2. Okay, understanding, right? We are converting seconds into minutes or into hours. Okay, so this is how we use the at offset feature. And the third way, so below query selects the historical data that present in the table before executing the query, before executing particular query that is specified by the query ID. Suppose if I can select, like I select star from table before. Okay, before. So here also we use before. Okay, before statement, and I have to give the query ID. So before executing this query, specified this query ID, what was the data present in the table, we can bring that data. Okay, so we can see that data. So if I want to insert this data into another table, what I have to do, insert into table, table name, and select star from this table. Suppose I don't even want to see, my requirement is not only just to see this data, but I want to insert this data into another table, previous copy of this table into another table. So I can put one insert statement above this, insert insert into table. Okay, this one we can give. Otherwise, if I want to create another table with this, create table, table name as, then select statement. Okay, so like that we can fetch the data, we can see the data, and we can store the data also into another table. So these are the three ways. Okay, but all the three ways are dependent on retention period. So if you don't see retention period anywhere, okay, suppose if I'm mentioning the timestamp somewhere about 2015 or 16, forget about 2015, 16, 21. Okay, we cannot bring the data back, because the maximum retention period offered by the highest version also, highest edition also, 90 days only. So whenever that 90 days crosses, even though you specify this, it won't work. The query itself will give error, because it will throw error like maximum retention period offered by your edition is just 90 days, like that. Otherwise, if you set it to 10 days, it will throw error like you set the retention period as 10 days for this table, so you cannot retrieve the data before the 10 days. Okay, so this is how we query the historical data by using three ways: at a timestamp, at offset, or before executing any statement. Okay, we'll see this in practical. Okay, and the next one is how to restore the objects. I told, right, by mistake or intentionally, if we drop any table, any object like table or schema or database, okay, it will not be removed completely from the system. Okay, so instead it will be retained in the storage layer. Okay, within that period. So based on the retention period we are setting, until that period, a version of that table will be stored, a version of that schema or database will be stored in the storage layer itself. Okay, after that retention period is completed, we cannot restore these objects anymore. Okay, so once that retention period is over, we cannot restore those objects, as I said. Okay, and the statement to get restore those objects is simple. So whenever you execute some drop statement, drop table, table name, so it will not be completely dropped, even though you cannot see the table in the UI, but it will be stored in the storage. Okay, and if you want to see the data again, you just have to execute one more command: undrop table, table name, or undrop schema, schema name, undrop database, database name, whatever you just dropped, or you dropped within the time retention period time. Okay, and if you try to undrop once the retention period is over, it will not, because after that retention period is completed, it will be completely deleted from the Snowflake. Okay, so this is how we restore objects. This is very simple. We just have to put undrop for a table or schema or database. Okay. So along with the time travel, there is one more feature called fail safe. Okay. So what is fail safe means? Fail safe provides a 7-day period. Give me 1 second. Okay. So failsafe provides a 7-day period during which historical data may be recoverable by Snowflake. Okay. So with the time travel, we can restore the data up to certain period of time. So again, okay, so there is a feature called failsafe offered by Snowflake. So after our time travel is over, okay, so another seven days period offered by the Snowflake. So that data will be stored in the Snowflake, but we cannot retrieve that data. So the problem here is we cannot retrieve the data which is stored in the failsafe zone. Okay, so if we want to retrieve that data after our retention period is over, so we have to contact Snowflake support. Even we cannot query the data, we cannot restore the data, we cannot do anything with failsafe data. So we have to contact our Snowflake support, and they can help us in restoring the data during that failsafe period. Suppose that 7 days is also over, then there is no way of getting data from Snowflake. Okay, so after failsafe period is over, there is no other way to recover the data. And data recovery through failsafe may take several hours to several days to complete. Okay, and and this failsafe period starts immediately after time travel retention period ends. I'll show you how it is. The failsafe period will be effective in the next slide. Okay, you understand, right? Failsafe. Okay, so once the data retention period is over, so Snowflake is offering a 7 more days of storing the data. Okay, but we cannot query the data, and we cannot restore the data, we cannot see the data at all from web UI. Okay, but it will be there in the storage layer, and only Snowflake support team can bring the data back and provide the data into some other table. Okay, so this is fail safe, and if you see this, you will easily understand. So what is the continuous data protection life cycle offered by the Snowflake? So if you see, the first thing, the current data storage. Suppose if I have a table or schema or database, it is stored in the storage layer. That means the current data storage, whatever we have. And if you see the second thing, suppose if I do some modifications, or if I do drop some tables or schemas, okay, so after that, for that object, the time travel period will be enabled. Okay, suppose till today I have some 1 million record, a table with 1 million records, and if I drop that table, so for the table the time travel will be enabled immediately. That means if we define 10 days of time travel period for that, okay, so the 10 days will be applied on the table. So it will store the data for next 10 days for that table, based on the retention period we are defining. So if we don't define any retention period, by default it is 1. That means it can store the data up to just 1 days. If we want to store the data for complete 90 days, we have to specify. So after that 90 days, what will happen? You don't need to bother. So you don't need to worry, like my retention period is over, I cannot bring back the data. No, still we have another feature called failsafe. Once your retention period is over, so Snowflake is offering another 7 days of uh, a period where you can retrieve the deleted data or dropped objects. Okay, but here the constraint is we cannot do that thing. We cannot do any operations, we cannot view that data, we cannot restore that data, but we have to contact Snowflake support. Okay, then they will help us in restoring those objects. So this is way how the data will be protected. Okay, up to certain period of time in Snowflake. So if you observe in traditional databases, this feature is not available, right? Suppose I have a table in traditional database, and if I drop the table, what I have to do? So if our admin team, database admin team, is taking continuous backups in other forms, definitely they will take into some storage areas like tapes. Okay, so we have to bring back the data from tapes. That a developer or tester cannot do that, right? Only admin can do, and it takes a lot of it needs a lot of approvals, and it takes a lot of time. But if we see here in Snowflake, any developer can bring back the data easily. okay, by using the time travel. No need to go for approvals and no need to wait for hours and hours. Within seconds, you can restore those objects or you can query the data before it was getting modified. Okay, that is the biggest advantage we have in Snowflake. Okay, understood? So I'm logging into my Snowflake account. Okay, I have prepared all the queries and I already uploaded this query sheet in the OneDrive. Let's see one by one all the queries. Okay, suppose first of all, okay, where can you see that retention period? Now, these many days we are operating with the tables. We are loading the data, we are modifying the data. Okay, so we are working with the data. But have you ever noticed this retention period anywhere? So if we want to see the retention period, okay, for the table we just have to execute this statement, show tables in the schema. Okay, for all the tables, if I want to see, if I want to for specific table, I can say like show tables. Okay, like table name we have to give, show tables like, and table name we have to give. Suppose if I want to see for all the tables in the public schema in my database, okay, I just need to execute this. If you run this query, okay, here it shows what are the tables present, what is the table name, what is the database schema name, and it's a table or view, or it's a transient table, temporary table. Okay, so it will show all those information and how many rows present in the table and how many bytes the table occupied. And here you can see the retention period time. Okay, so retention period time here you can see. Okay. For my testing I was doing something, I that's why I set it as 8 for this table, but by default it is 1. Okay, so here you can see for tables, if you want to see the retention period for the schemas, okay, you can just execute this show schemas in database, and we have to give the database name. So our database name is my own db. If I run this, it will show all the schemas, and here it shows the default retention period. If we don't set anything, so here it shows the default retention period as 1 day. Okay, and if I want to see the databases retention period, I can just run show databases. Okay, so for every database, suppose we have 3 databases, my own db, snowflake, and whatever here there are. Okay, retention period is 1 day for the databases also. Suppose if I how this retention period set. Okay, let's see how to set this retention period at the time of table creation. We'll see. Suppose I'm creating one sample table. I'm not loading any data, but I'm just creating some time travel table. Okay, time travel underscore ex. This is the just I'm giving some random name. Okay, create a replace table name. Okay, and here I'm not giving any retention period or time travel period. So if I do like this, okay, so my table time travel underscore ex has been created, and let's see what is the retention period for this. Okay, if you see, the retention period for this is 1 day, because I did not specify anything at the time of table creation. That's why by default 1 came. Suppose if I want to set it to 10 days, how I have to set. So this is the syntax for creating table with the retention period. Create or replace table. The table name we have to specify and the list of columns, and this is how I have to specify data retention time in days. Okay, this is the keyword. This stores the retention period time. Okay, so this is the keyword we have to use for setting up or for altering. Okay, this is the keyword we have to use. Data retention time in days, data retention time in days equals to 10. I am setting. So let's create this table again with the 10 days retention period. Okay, so my table has been created, and if you see now show table, so now it is showing 10 days retention period. So that's how you can mention your retention period at the time of creating table itself. Suppose at the creation of my table, I specified 10 days. Okay. But later I realized 10 days is not enough and I want to increase it to 15 days. Okay. How can you alter the retention period at later point of time? Suppose for the same table I just had created, I'm altering the retention period to 15 days. How we can do? Alter table name, set data retention period in days equals to 15. We just have to need to execute one alter statement where I am updating the retention period from 10 days to 15 days. Now let's see what is the retention period for this table. And if you see, it was updated to 15. Okay, you're understanding, right? This is all simple queries. These are all not needed in real time, but for your understanding I'm showing. Okay. How to see the retention period for a table, how to see the retention period for database or schema. Okay. How we can mention the retention period at the time of table creation, and how we can change it later point of time. So this is how we have to do. And let's come here. Okay. So I want to see now I want to show you how we can use those queries specified here, right? So querying the historical data by using at a timestamp, at offset. Okay, before query id I want to show that. So before executing that, what we have to do, we have to prepare some sample data for that, right? Suppose I for the three ways I'm showing you three cases. Okay, how we can retrieve the data, and I'm utilizing some the tables already present in my my database. So we had created some tables in the public schema, right? These many days, customer data, customer large. Okay, employee data, orders, time travel x. Okay, so these are the tables we had created these many days. So I'll use the same tables. Okay, I'm not loading any fresh data into tables. Okay. So suppose select there is a customer table in my public schema. I'm going to update some records in this table. Okay. Suppose here I'm just selecting the data for this customer. Okay. So let's see first of all whatever the fields present in the customer table. Okay. So in the customer table I have customer id, customer name, email, city, state, and date of birth. Okay. So now I want to modify one of the customer data. So suppose let's see the data present for this customer. Okay. So for this customer the name is Jeremy Nicholson. Okay. And I want to set it as some random name abcxyz. Update the table, set customer name equals to this one, and where customer id equals to this customer id. So let's update this. Okay. So one row got updated and I want to see the updated row now. Okay. So if you see the customer name has been changed to abcxyz. Okay. Now after some time, if I want to fetch this, okay, how can I get this data? We'll see in some time. Okay. Because it takes we need at least 2 or 3 minutes, right? Then we can specify the time period and see it. So before doing that, let's modify some more data for other ways we have for fetching the historical data. So in case 2, what I am doing, instead of modifying the data, I want to delete some data, okay, into another table. So the earlier table was customer table. Now I am deleting some data into employee data. Okay, just run this query, whatever the data we have in this employee data. So if you see, there are 300 rows in this table. Okay, and I'm just fetching the data for where id equals to 1. Select star from the table where id equals to 1. So for id, how many records I have? Okay, 3 records I have for id 1. So let's delete all those 3 records. Delete from this table where id equals to 1. Okay, so what happened? Number of rows deleted is 3. 3 rows were deleted from the table. And just for this one, I'm just selecting this. Will explain you why. Okay, I'm just saving this timestamp at what point of time I have deleted the data. Okay, before this timestamp we can fetch the data again. Okay. And I have deleted 3 records, right, for ID 1. For not only 3 records, for whatever the records present with the ID equals to 1, I have deleted. So let's see those records present in the employee data table or not. So if you see, there are no records with employee ID 1, but still, because of the time travel, we can see those records. We can get those records. Okay, we'll see in some time that one also. And the third case. So before executing any query ID, if I want to fetch the data, okay. And now here I am taking the orders table from public schema. So let's select whatever the data present here. In the orders table, I have order ID, the amount, profit, quantity, category, and subcategory we have. Okay, let's see the data, whatever present for this specific order ID. Okay, so for this order ID, how many records I have? I have some 8 records, and amount value is varying. Okay, there are different values in the amount field. But what I'm going to do now, I'll set all the values to 0, amount to 0 for this order ID. Update table, set amount equals to 0, where order ID equals to this one. Okay. So what it is saying? It has updated 8 records. Okay, it has updated 8 records, and let's see the updated data in this table. Okay, so if you see, for all the records with order ID, this one, the amount is set to 0. But if I want to bring back this, how can I do? Okay, for this, what I am doing, I'll go and fetch the this one, query ID. Okay, so how we can fetch the query IDs? So in the history tab there will be. Okay, so what is the query I updated? So this is the query I have updated, right? So update my own table, set amount equals to 0. So if I want to see the data before this query, then I have to get this query ID, right? So you can get query ID from here. Okay, so let's just take that query ID and store somewhere, save somewhere. Okay, so I'm just mentioning my query ID here for later purpose. Okay, so now we have 3 cases. So we have modified some data, right? So for the first case, we have modified the customer name as ABCXYZ, and in the second case, I have deleted some data from the table, and in the third case also, I have modified some table, and I just capturing the query ID for that one. Now let's see, it's almost 2 minutes, right? So now what we can do, we can see all the ways of fetching the data back. Suppose just before doing that, okay, this is the first case, right? So let's select first what is the data present for this customer, okay, in the current table. Now it is showing the name as ABCXYZ, but before 2 minutes, it was with different name. So I have realized, like, after some time, after 2 minutes or 3 minutes, I realized, like, oh, by mistake I updated the data. Now I want to see what is the customer name before 5 minutes, or before 2 minutes, or before 1 hour, or before 2 hours. So before that time, if I want to see what is the data present in the table, so I have to execute a query like this: select star from, okay, customer table at offset. Whenever I say before some time, okay, exact time, if we know the exact time, like how many minutes or how many hours, okay, we can do like that. So let's see what is the data present in this table for this customer ID. So the syntax is simple. Okay, select star from this table at offset, and we have to give the time in seconds. So if you cannot calculate the seconds, you can just put it into symbols. Okay, minus 60 into 2, okay, or minus 60 into minus 60 for 1 hour. Okay, we can see like that. Okay, let's see. Suppose just a minute back, I want to see what was the data present in the table. Okay, so I don't want to see all the data. I'm just fetching for this customer ID. Okay, let's do just a minute before what was the data present in the table. So if you see a minute before, it was ABC XYZ only. It's more than 3-4 minutes, right? We updated the data. So let's increase it to 2 minutes. Okay. And let's see the data. So 2 minutes back also it was ABC XYZ. Okay, so let's increase it to 3 minutes. So 3 minutes back also it was like that. Let's increase it to 4 minutes. Okay, 4 minutes back also it was like that. Let's increase more time. Okay, let's put 10 minutes. So now you see. Okay, so whenever I give 10 minutes, so the data was like that 10 minutes before back, 10 minutes before in the table. So earlier, so what is the current data we have? ABC XYZ, the customer name. But 10 minutes back, how it was? It was with the this name. So you are understanding, right? How I am fetching the data. Suppose 1 hour I want to check for 1 hour before, okay, or 2 hours before, okay, I can just say like this. Even 2 hours before also data was like this only. Let's see. See, even 2 hours back also the data was like this. Suppose I want to check some 25 hours back. So we cannot fetch because the retention period we set for this table by default is 1 day. 1 day means 24 hours, and you cannot fetch beyond the 24 hours. It is showing you, right? So you cannot fetch the data beyond the retention period specified for that object. You're understanding, right? This is very important. You will get some questions, okay, on this. How you can fetch the data that was present in the table 5 minutes back. So you have to put like this. No need to even put the condition, okay. So you can just say like this: select star from table, select star from table name at offset. We have to use whenever you say in seconds or minutes, okay, you have to use offset. Whenever they ask you certain time period before the time stamp, okay, you have to put at a time stamp. Okay, some minutes back or some hours back, if they ask you, you have to use offset. You have to tell offset. If it is before particular time stamp, you have to use at time stamp. Okay. Understanding, right? So you understand now how to use at offset. Okay, so this is how we have to put. And in the second case where I have deleted some data from the employee data table, let's see the same. Okay, so where is my query? Select star from data. So where is my case 2? Okay, so let's see for this employee data, what is the for this employee ID1, what is the data present in this employee data? So there are no records, right? But if I use time travel period for this, okay, so I just captured the time period here, right? Just for our testing purpose. So let's put this timestamp value there. Okay, select star from this table at timestamp. Okay, and okay, so this is the timestamp where I captured, but I executed my query just before this. Okay, let's see what will happen. Select star from this table at timestamp. Okay, so we are mentioning the hard coded timestamp, right? That's why I'm converting this into a timestamp. So whenever you mention something within the single quotes, it is a characters. It is a string field. So if we want to make it as a timestamp, you just have to put while explaining the loading semi-structured data, I explained you. Whenever we want to cast from one data type to another data type, we just have to use double colon. Okay, and the data type we have to specify. So let's execute this statement. So I have that data before the timestamp. I have the data for this ID. So if I see the current data, I don't have this data, but at the whatever the time I have taken, right, before that timestamp, we had data in the table, right? That's why I'm able to fetch the data even though we had deleted it. Okay, you're understanding how to apply offset and how to apply timestamp. If it is some time ago, some minutes or some hours ago, we have to use at offset. If it is before particular timestamp, okay, we have to use at offset up at timestamp, okay, and we have to specify timestamp here. Okay, and let's go to the third case. Okay, after explaining this, I'll take questions if you have anything. Okay, so in the third case, what I did, okay, this is case 3. Okay, so before that, where is my case 3? So let's see the data here. Let's see what is the current data for case 3. Okay, so if I see this, for all the orders, for this order, I am setting all amounts to 0. But if I want to see executing any particular query, any statement where I had updated my data, if I want to see the data, I just have to take that query ID. That's why I captured the query ID at that point of time. Let's update this query ID. Okay, and let's try to run now. Okay, so if you see how we have to apply this, select star from table. Okay, before before statement we have to give, this is the keyword, at offset, at timestamp, before statement. Okay, these are the 3 important keywords: at offset, at timestamp, before statement. Statement means the query we have executed, and we have to pass the query ID. And I don't want to see the data for all records present in the table before that statement, but I want to see only for this order. Okay, that's why I'm just mentioning a where class, where order ID equals to C. And when I execute this, you can see this, right? You can see the amounts. And if you see the current data, all amounts are present with like this. Suppose if I want to create a table with this data, whatever present in this table, okay, into another table before executing this query ID, what I have to do? Create table. Okay, I'm just putting underscore time travel as okay. I'm putting this statement, and I want not only for this customer ID, order ID, I want to store the data for entire table. Okay. Okay, so how my statement looks like: create table, okay, different table name as select star from this table. Okay, before executing this statement. Okay, let's run this. A table has been created, and now let's see the data present in the both tables for this order ID. Okay, so here it is, order underscore TT. So in the current table, okay, whatever the table present, so the amount is like this, okay, for this order. And if I execute this one, okay, the amount is like this, the actual values we have. Okay, for this order only I'm seeing the data, that's why I'm getting only 8 records. And suppose if you want to see the data in this table for all other orders, okay, because we did not update them, and let's see whatever the values. So for all the other orders, only this 601 order it is set to 0, but for all other orders they have certain values. Okay, I hope you are understanding. If not, please ask me the questions. The questions are important. Okay, so I'll go to the next thing later, but I want to take any questions if you have now. I'm trying to give detailed explanation, but still if you have anything you can clear, because this is very important, not only at the not only like for interview purpose, but in real time also this is very important. Okay, you will get some help from Google, but before googling you should know what you have to Google, right? That's why. Okay, so you just remember three ways. There are three ways to retrieve the data. Okay. So before some time and before particular timestamp and before executing particular statement. Okay. And keywords are at offset, at timestamp, and before statement. Okay. If you remember these three, you can easily answer the questions asked by the interviewer. Okay. Just three keywords: at offset, at timestamp, before statement. These are the three ways to fetch the modified data or deleted data. Okay. Now let's see how we can restore the objects. Okay. Restoring the objects. Okay. Suppose I'll delete some table and I'll try to restore the table. First, before that, I want to see what are the tables present with the name like customer. Okay. Show tables like I'm just giving the customer and percentage symbol. You know, right, how to view the strings or the tables with like. Okay. The percentage symbol I'm giving. That means all the tables starting with the name customer, it displays. If you see how many tables are there are four tables. Okay. So customer data table, and customer large. Okay. But I want to drop only one table. Okay. That is with name customer. Okay. So what is the statement for that? Drop table name. I am just dropping this table. So don't worry. So in traditional databases, if you do like this, gone. Okay. You cannot bring it back. You have to suffer like anything. In production environment, definitely you will not have access to drop the tables or delete data. But in dev and test also, it is important, right? So if we drop any tables or if we delete some data, it's very important data, then it's very hard to bring back that data. Now I dropped this table. So let's see what are the tables present now with this customer. So earlier we had four tables. Okay, customer data, and four tables. But if you see, my table was dropped, and you can see here also earlier. Okay, what schema this is? Public schema. Okay, so earlier I did not refresh because it is present here still customer. If I just refresh this left pane, now you see the customer, this one is not present. Okay, only customer data table is there. Now suppose by mistake I did that, by mistake I dropped the table. Now if I want to bring back the table, how I can do? Simply undrop table name. Okay, so now it is saying table customer successfully restored. So if you want to see, just refresh it here, and now you can see here customer. So if you want to see from query, show tables like customer, again my customer table was restored. Okay, so this is how we can restore the tables by using this thing, time travel. And the same way we can apply for schemas and databases also. I'll quickly show. Okay, show schemas present in the database my own db. So these are all the different schemas. Okay, there are 7 schemas now. Okay, so if you just take stage tables is also one of the schema, and I'm going to drop the table. I am going to drop that schema, drop schema stage tables. Okay, schema was dropped, and let's see now if that schema is present. Okay, so here we have stage tables, right? Just refresh it here. Now that is not available, only till public we have. And so if I want to see that back, undrop schema name. Now you just see it is saying schema successfully restored. Just refresh this, and you can see the stage tables here, and you can see from here. So our stage tables schema was restored. Like this you can apply for the databases also. Okay, so this is very simple restoring. Okay, and the cost is important. As I told, more retention period, it will cost more. Okay, if I want to see, okay, how the storage cost for uh, this time travel period and fail safe period. So how we can see that, how many bytes it occupied. Okay, how many time travel period bytes it's occupied. If I want to see all those stats, we have one particular query. No need to change anything. So the query is like select star from Snowflake dot account usage dot table storage metrics. Okay, so this is the so I told, right, whenever we create Snowflake account, two schemas come will by default. One is some sample data and one is some Snowflake account related schemas. Okay, so here all the data will be stored. This is for our testing purpose sample data, and this is for our all account level information. Okay, so if I want to see these are the schemas present in this Snowflake, and this is one of the schema account usage. And if I want to see what are all the storage metrics for each and every table in my account, okay, so I can just fetch data by using this statement. Select star from Snowflake database dot account usage schema dot the table name is this one, table storage metrics. Let's see how it looks like. Okay, so if you see here, these are all the tables present in my database. Okay, across the databases in my Snowflake account, complete Snowflake account. So these are the tables present. Okay, so there are some 39 tables present as of now. All 39 are not active. Okay, because of time travel period is enabled. Okay, there still we can see some deleted tables. Okay, so this table was deleted, and okay, and if you see wherever the deleted is true, so we can see those tables still here. Okay, so after 7 days after our retention period is over, after fail-safe period is over, you cannot see those tables even here. Okay, it will not show here also in this list. They won't be, you cannot find them. And if you want to see, okay, so how the storage is for this tables. Okay, so here there are some three important fields. Okay, so no one will ask you the question how can you see these things, but just for your information I'm showing this, how the cost is effective for a time travel and Snowflake. So these are the actual bytes for this table. Okay, that means the current storage, and these are the bytes for time travel storage, and these are the bytes for fail safe. Okay, suppose for this table I had there was some data in this table, but I have deleted the data. So what happened, the data was for the data, even the time travel period was completed and it moved to fail safe zone. Okay, so next 7 days the data will be stored in the fail safe zone for this table. After 7 days, what will happen, this will also will become 0. So for whatever the tables we had deleted the data, for those you can see the fail-safe bytes here. Okay, and as we did not do any modifications for most of the tables, so I don't see any time travel bytes here. So we just did some one row update like that, right? For that data, there will not be any bytes, but we'll show you in practical how you can see some data here, some values here. Okay, suppose if you want to understand more clearly, okay, select star from this particular table I am selecting. So this is the largest table I have in my database with some number of rows. Okay, so if you see this, with this table, with this name I have three tables. Okay, but if you see here, only one of them is active and the remaining are not active, remaining two are deleted. That means I had executed create or replace table. So whenever you do some create or replace, what will happen, the table will be dropped and another table will be created. So by this by this field you can say this is active table or deleted table. So if it is false, that means that is the active table. If the deleted is true, that means those tables are not active. So what is the current table I have? Customer large, and I have some how many records I have in the table, I can see that, right? Okay, there are no row count here, but you can see here active number of bytes. This many number of bytes it is having, and there is no time travel for this because the table is still here. Okay, and if you see the fail safe bytes, even because this table is still here. Okay, so there is no this one fail safe bytes. Suppose if I want to more if I want to clearly understand in more details, okay, in GB. So this is in bytes. If I want to calculate the same data in bytes, okay, how we can do? So we can simply do like this, okay. Select this one, and let's select only for particular table, okay. Okay. So what I'm doing, I'm just converting the bytes into GBs, how many GB it is occupying. So because we can, it is little confusing in the number of bytes, right? So if you see here now, you can clearly say the table has occupied 0.37 GB, okay, and the time travel is 0 and failsafe is also 0. So if you want to mention for any schema in particular, okay, so I can quickly show you if you want, okay. So create schema ABCXYZ schema, okay. I want to set the retention period, right? Simply just copy this. Okay, so for this schema I set the retention period as 10 days. So you can see that, like show schemas, like ABCXYZ. So now if you see, so the retention period for this schema is 10 days. And if you create any table, okay, under this schema, what will happen? Let's see. Create a table, we'll do this same here. So instead of public, I'm giving the schema name as, okay, ABC XYZ. So now I have created this table. Let's see. Okay, show tables like this. See, it is 10 days now. So by default, whatever you set for the schema level, it will be applied for all the underlying tables. But if I want to specifically mention 50 this one as 15 days, okay, like 20 days, let's say. Now see, it is 20 days. If you specifically for any table, it will be like that. But by default, so suppose for your database, you are setting time travel period as 30 days. So for all the tables you are going to create under that database or schemas or tables, okay, it will be 30 days only. If you want to change it for any particular schema or table, you can explicitly mention for that. Okay,